This is part 2 of your winter break assignment. In this video, you will be learning how to draw orbital diagrams. So the goal of this video is to be able to write orbital diagrams. During this video, please be sure to do all 4 of the things listed below in your notebook. I will be collecting notebooks when you return from break. Just to recap from our first video about electron configurations, the following is an electron configuration for chlorine. Remember, those red numbers represent the energy level, the green letters represent the subshell or sublevel. Those are the same thing. And the black numbers represent the number of electrons in each subshell. So in the first energy level, in the S subshell, there are 2 electrons. In the second energy level, in the S subshell, there are 2 electrons, and so on. So you can get the electron configuration just by looking at the periodic table. You can read the periodic table from left to right, just like you read a book, in order to figure out the electron configuration. Notice we have the S block, the P block, the D block, and the F block. So, if we have silicon, number 14, in this nice red box, and we look at the periodic table, we can determine its electron configuration. So we start with 1s1, 1s2, 2s1, then 2s2. So notice, our first 2 periods, in our first 2 periods, the S block is now covered by these blue dots, which we're going to call electrons. And we're going to continue to cover elements with blue dots until we reach silicon, because once we reach silicon, that means we have 14 electrons, and we'll have its total electron configuration. So we finished our 2s block because we have 2 electrons, so we need to move to the 2p block. So now we have 2p1, 2p2, 2p3, 2p4, 2p5, and 2p6. There can be 6 electrons in each p subshell, and now that we have 6 electrons in the second energy level p subshell, we can move on to the third period, the 3s. So now we have 3s1, 3s2. Okay, so our s orbital is totally filled, so we move on to 3p. 3p1, and 3p2. So we now have a total of 14 electrons, 2 plus 2 plus 6 plus 2 plus 2, and we have reached our element silicon. So use the periodic table below and write the electron configuration for iron in your notebook. Okay, just to point out, this is 3D, so notice that 4s comes before 3D. Now we're going to talk about how to draw orbital diagrams. An orbital diagram is a picture that shows how electrons fill orbitals. The example below shows an orbital diagram for phosphorus. So notice that the electrons are represented by arrows. Notice how many arrows are in each box, the directions the arrows are facing, and try and predict how these orbitals are actually filled. There are 3 rules for filling orbital diagrams. The first is called Aufbau principle. Electrons fill the lowest energy orbitals first. So here's our lowest energy. So electrons are going to fill our 1s orbital, or our 1s subshell. There's 1 orbital here first. So then they'll go to the 2s subshell. Then there are 3 orbitals in the 2p subshell. Then they'll go to the 3s, then the 3p. Then I want you to notice that even though there's a 3D here, the 4s is actually lower in energy than the 3D. So after filling the 3p, electrons will go to the 4s, then the 3d, then the 4p. Then notice again that the 5s is lower in energy than 4d, so they'll go to the 5s, and then electrons will finally fill the 4d. The order is displayed below. And it's also shown on the periodic table. So you don't actually have to memorize this order, because remember, this is our S block. So S's go 1, 2, 3, 4, 5, 6, 7. Our P's, we start at 2. 2, 3, 4, 5, 6. Our D's, we start at 3, so S's start at 1s, P's start at 2s, D starts at 3, 3, 4, 5, 6. Okay, and notice we have 1S, then 2S, then 2P, then 3S, then 3P, then 4S, and then 3D, then 4P, 5S, and then after 5S we jump down to 4F. So our S's start at 1, our P's start at 2, our D's start at 3, and our F's start at 4. The second rule is called the Pauli exclusion principle. Only 2 electrons can go in each orbital, and they must have opposite spins. So, 2 electrons can go in one orbital. Each orbital is a box, remember? And they have to have opposite spins. This is because electrons are negative, so they repel each other, and in order to decrease that repulsion, they spin in opposite directions. The third rule is called Hund's rule. 1 electron will fill each orbital before electrons pair up. You can think about this as a public bus rule. If you are on a public bus or the metro, you're not going to sit next to a stranger if there are empty seats around. You're going to wait until the last seat available, until you have to sit next to somebody in order to sit down before sitting next to somebody. So, again, electrons fill the lowest energy levels first, so once the 1s orbital is filled, then they go to 2s. Now notice that the 2p has 3 different orbitals. So an electron is not going to fill like this. We're not going to have this electron, that second electron, here, because there are still 2 empty orbitals. So instead, that electron is going to go here. And when electrons fill different orbitals of the same energy level, they all face the same direction. So once we have all 3 p orbitals filled, then they double up. So this is how orbitals are filled. Okay? So notice that all 3 principles are being followed. We started at the lowest energy level. There are 2 electrons with opposite spins, and they pair up only once there's 1 electron in each orbital on a sublevel. So to create the orbital diagram for calcium, which has 20 electrons, we just place 20 electrons into our orbital diagram according to our rules. And we end with 4s. If you look at a periodic table, calcium is in the s block in the 4th period. And it has 2 electrons in that s block. It's the second element over. And we write the electron configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Cobalt has 27 electrons, so we fill from the lowest energy to the highest energy, and we pair them with opposite spins, and once we reach 27 electrons, then we stop. So this is the orbital diagram, and this is the electron configuration. So your assignment is to write the orbital diagram and electron configuration for the following elements in your notebook. Okay, so you're going to do all 5 of these elements. Now, with orbital diagrams, you can write all of these horizontally. So you could put 1s here, 2s here, 2p, then 3s, then 3p, 4s, and 3d going horizontally. Or you can show the difference in energy. That's really up to you. Both are correct orbital diagrams.